Hello, my name is Ronaldo Davis, and today I will be presenting on pure tones and complex sounds. Pure tones are single frequency sounds, such as the sine wave on the right. They are produced, they can be produced by either human speech or hearing tools. Although, although they are rare in human speech, they can be produced by monotone humming. Speech production. Pure tones are produced by steady vibrations of the vocal folds with minimum involvement of articulatory structures. Pure tones lack harmonics and fundamental frequencies. Articulatory movement. Vocal folds maintain constant tension while vibrating and minimal usage of the tongue, lips, and other vocal structures. Auditory processing and application. Pure tones are assessed in the primary auditory cortex found in the temporal lobe. Here, the auditory cortex processes single frequency sounds. Pure, pure tones are useful in the foundation of auditory research, such as hearing tests and pitch training. With hearing tests, individual pure tones help identify hearing thresholds in hearing tests with individuals with hearing loss. And with pitch training, pure tones are used to develop consistent pitch control with singers and individuals with intonation issues. These pure tones are essential for hearing assessments through audiometry and also are valuable in aiding individuals refine their intonation and voice control. Complex sounds. Complex sounds are composed of multiple frequencies combined or multiple pure tones combined. Complex sounds involve harmonics and a fundamental frequency. Complex sounds require complex articulation, articulatory movement, and resonance shaping. Examples include human speech, music, and laughter. These sounds are critical for natural communication um, and encompassing speech and environmental sounds. Harmonics. Vocal cords vibrate at a fundamental frequency to generate harmonics. The shape of the vocal tract filter harmonics to create formants, which are vowel sounds. The shape of the vocal tract and by filtering harmonics produce resonance. Articulatory movement. Tongue, lips, jaw, and the soft palate work together to regulate airflow and create resonance to produce distinct sounds. Dynamic control. Complex sounds involve rapid, precise coordination to produce pitch, tone, and articulation. Auditory processing and application. Complex sounds involve complex higher auditory regions to evaluate, produce phonemes and prosodic features. The main areas include the superior temporal gyrus, which decodes patterns, the Broca's area, which plans speech production, and the motor cortex, which exacts articulatory movement. Problems with complex sounds are useful in diagnosing speech disorders such as apraxia and dysarthria. Key takeaways and implications. Pure tones help assess baseline auditory capabilities for hearing research and training. Complex sounds are vital in speech therapy, language acquisition, and development of hearing technologies such as hearing aids and cochlear implants. Together, the study of pure tones and complex sounds help bridge the gap between basic auditory mechanics and the intricate demands of human speech and communication and clinical and technological innovations. Here's an example. Here are an example comparing pure tones and complex sounds. We'll be moving to a YouTube link after the video, after the ad.
It's hot and toxic.
Okay, so this tutorial is to show you the difference between a pure versus a complex tone in frequency analysis. So first I'm going to play for you a sine wave, and I'm going to let you look at what it looks like on the EQ screen with the analyzer.
This is a
Okay, so
hearing
you can
tool.
see that when you listen to a
A
sine
sound
wave,
tool.
it is just one frequency, and in this case this is a 1000 hertz frequency. Now, if I go into a different instrument, such as, let me go
This
into the
is an
pianos
example of
first.
musical instrument to
Go to the
produce a
piano and the
complex sound.
Steinway. I'm going to put the analyzer on, and I'm going to play the same tone. I'm going to show my keyboard here quick. All right, so the tone that you heard was 1000 hertz, which is about a B4. That's this tone. And as you can see, this tone has several frequencies present. Specifically, 1000 hertz is the lowest of them, but then it has a bunch of other ones as well. So that's an example of a complex tone. And that's
Here are my references. Thank you.